Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be doing Unit 5, Lesson 4. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your notes. Today's main topic is solving rational functions, part 1. So far we've taken rational expressions, we've simplified them, we've added, subtracted them, we've simplified complex fractions, which is just a whole bunch of rational expressions in one giant fraction. And then today we're going to take those skills and apply them to these things called rational equations, which I just realized that should say rational equations. Solving rational equations, part 1. These aren't functions. Okay, so I will solve rational equations, checking for extraneous solutions and stating any restrictions on the variable. Mastery will be demonstrated by scoring at least 80% on the extra practice. So here are the 4 steps we're going to use to help us solve rational equations. The first thing we're going to do is we're going to factor. Every time we have a rational expression, we want to factor it as much as we possibly can. Then we're going to determine what the least common denominator is for all of our rational expressions in our equation. We're going to take that LCD and we're going to multiply the equation by the LCD. Then something magic happens when we do that. When we multiply the entire equation by the least common denominator, in step 3, we're going to simplify everything and all the denominators will cancel out. When you solve rational expressions this way that I'm going to teach you today, you're going to end up canceling all your denominators and it makes it super easy to solve the equation from there. Then step 4, solve for the variable, but you have to check for extraneous solutions. Remember, an extraneous solution is an answer you get that doesn't actually work. That doesn't actually work. All right. So for example 1, we are going to actually change this so there's no x here. We're just going to do 5/4 minus 3 over x is equal to 1/4. We're going to solve this rational equation. So our first step is to factor, which in this one we don't need to factor. Then we need to determine a least common denominator. So our least common denominator needs to include at least one of every factor from each denominator. So this denominator has 4, our LCD needs to include 4. This denominator has x, it needs to include x. This one has 4, our LCD already has 4 in it. So our least common denominator for this one is 4x. Then we're going to take the entire equation. So we're going to take 5/4 minus 3x is equal to 1/4. And we're going to multiply this entire thing by 4x. So to do that, we need to distribute the 4x to the 5/4, the 3 over x, and the 1/4. So that's going to look like this. 4x times 5/4 minus 4x times 3 over x and 4x times 1/4. Now remember, 4x is technically over 1. And when I multiply a fraction by a fraction, I multiply across. So I'm going to multiply the 4x by the 5, the 1 by the 4, the 4x by the 3, the 1 by the x, the 4x by the 1, the 1 by the 4. So let's do that. 4x times 5 is 20x. 1 times 4 is 4. 4x times 3 is 12x. 1 times x is x. 4x times 1 is 4x. And 1 times 4 is 4. So notice something really handy is about to happen. 20 divided by 4 is 5. Then 5 times x is 5x. Minus x divided by x is 1. Then 12 times 1 is just 12. 4x divided by 4. Well, 4 divided by 4 is 1. 1 times x is just 1x. And now we can solve. So I'm going to move the 5x to the other side. I get negative 12x. Negative 12 is equal to negative 4x. I'm going to divide both sides by negative 4. And I get x is equal to positive 3. Now, before I say that's my final answer, I need to double check that x is allowed to be 3. So I need to look back at my original equation. When I do that, I notice the only variable in the denominator is x. So the restriction on x from that would be x can't be 0. Well, for our final answer, we didn't get 0. We got 3. So x is allowed to be 3. So x equals 3 is our solution. All right, so part B, 3 over 2x minus 5 over 3x equals 2. I'm going to walk you through the steps for this problem. So step 1, I need you to find the least common denominator. We don't have to factor this one. There's nothing to factor. You just have to find the LCD. So tell me, what is our least common denominator? So our least common denominator is 2 times 3 times x, which is just 6x. So now you're going to take this whole equation and you're going to multiply it by 6x. So 3 over 2x minus 5 over 3x is equal to 2. Distribute that 6x to each of these and then simplify it and see what equation you get to solve then. Go ahead and give that a shot. All I want you to do is multiply by the 6x and then simplify. What do you get? All right, so 6x times 3 is 18x over 2x. 6x times 5 is negative 30x over 3x. And then 2 times 6x is 12x. Then when I simplify that, 18 divided by 2 is 9. And then x divided by x is just 1. 30 divided by 3 is 10. X divided by x is just 1. And then this is equal to 12x. Now we can go ahead and solve this. 9 minus 10 equals 12x. So 9 minus 10 is negative 1 equals 12x. Divide both sides by 12. X is equal to negative 1/12. Now we need to double check that x is allowed to be negative 1/12. So what is our restriction on the variable from that very first equation? So what would make 2 times x, 2 times what would be 0? And 3 times what would be 0? Well, 2 times 0 would be 0. So x is not allowed to be 0, and neither is x here, because 3 times 0 would be 0. So x can't be 0, which isn't the solution we got, so we're fine. X is allowed to be negative 1/12. All right, so let's do some more complicated examples. So part A, we've got x over x minus 3 plus x over x plus 3 is equal to 2 over x squared minus 9. So we need to factor what we can. X over x minus 3 is fine. That doesn't need to be factored. But 2 over x squared minus 9x, that's a difference of squares. So we can factor a difference of squares by taking, well, x times x would get us that x squared. 3 times 3 would get us 9. And then one has to be positive and one has to be negative. So then let's figure out what our LCD would be. So our LCD needs to include x minus 3 from here. It needs to include x plus 3. And then it needs to include x plus 3, which it already has, and x minus 3, which it already has. Okay. So now we take this entire equation and we multiply it by x minus 3 times x plus 3. So we're going to take this whole thing and we're going to multiply by x minus 3 times x plus 3. So I'm going to write out how this would look if we actually did this. We're going to distribute it to the first fraction, the second fraction, and the third one. So this is what it's going to look like. You're going to have x minus 3 times x plus 3 times x over x minus 3 plus x minus 3 times x plus 3 times x over x plus 3 is equal to, and then you're going to have x minus 3 times x plus 3 times 2 over x plus 3 times x minus 3. Okay. But check it out. What's going to happen here? So remember, this is technically over 1. So is this one. So is this one. And we multiply across. But when we multiply this out, what's going to end up canceling for us? Because isn't x minus 3 divided by x minus 3 just 1? So what we're really left with here is x times x plus 3 over 1, which is just x times x plus 3. Plus What's going to cancel here? X plus 3 and x plus 3. So we're just left with x times x minus 3. Then for this one, we're going to have x minus 3 divided by x minus 3 is 1. X plus 3 divided by x plus 3 is 1. And we're just left with 2. Well, technically 2 over 1, but what's 2 divided by 1? That's just 2. So now we have an equation that we can solve. Well, we've got some distribution we've got to do here. We're going to have x squared plus 3x plus x squared minus 3x is equal to 2. Then we have 3x minus 3x cancels. X squared plus x squared is 2x squared. 2x squared equals 2. Divide both sides by 2. We get x squared is equal to 1. Well, there's two ways we can solve this, and I'm going to show you both ways. So the first way is I recognize x being squared. To cancel that square, I just square root both sides. The square root of x squared is just x. When I square root 1, I get 2 answers, plus and minus 1. So I have 2 solutions, positive 1 and negative 1. Then the other way you could solve it is I recognize I have a degree 2 polynomial. It needs to be equal to 0 for me to solve it. So I subtract 1 from both sides. X squared minus 1 equals 0. It's a difference of squares. I can factor it. X plus 1 times x minus 1. This factor would get me negative 1. This factor would get me positive 1. So I have x equals positive and negative 1, which is the same answer I got before. So either way you solve it is fine. It doesn't matter. Now our 2 solutions are positive and negative 1, but we need to make sure we're allowed to have those as our solutions. So we need to look back at the original equation. Okay. What would make x minus 3 0? Positive 3. So we know that x cannot equal positive 3. X plus 3 to be 0, x would not be allowed to be negative 3. And then negative 3 and positive 3. We already have those. Well, we got positive and negative 1. So it looks like those answers are allowed because the restrictions were for 3 and negative 3. All right. So if you ever get a solution that matches what x your restriction, then you know that that's not actually a solution. That's an extraneous solution because x is not allowed to be that number. But our examples haven't gotten us there yet. All right, so now I want you to try part B. X minus 1 over x squared plus 3x plus 2 plus 2x over x plus 2 is equal to x minus 1 over x plus 1. So the first thing you need to do is factor what you can. So this first denominator will factor. The rest don't need to be factored. Go ahead and factor that on your own. What do you get? So you should have gotten x plus 2 times x plus 1. Now identify your least common denominator. For all of these fractions, what would our least common denominator be? Go ahead and identify that on your own. So you should have gotten x plus 2 times x plus 1 as your LCD. So now we're going to take this entire function and we're going to multiply it by x plus 2 times x plus 1. Give me 1 second. Okay, so we're going to have x minus 1 over x plus 2 times x plus 1 plus 2x over x plus 2 is equal to x minus 1 over x plus 1. And we're going to multiply this whole thing by x plus 2 times x plus 1. So you're going to distribute this. You're going to multiply all of these numerators by x plus 2 and x plus 1. Then you're going to simplify what you can. All of your denominators should end up canceling. Then I want you to tell me the equation you get after you multiply each of these fractions by the LCD and you simplify. What equation do you end up with? Go ahead and give it a shot on your own. So you can see that I've distributed the x plus 2 times the x plus 1 to each of those fractions. Now I'm going to cancel what I can. So x plus 2 divided by x plus 2 will cancel. X plus 1 divided by x plus 1 will cancel. I have x minus 1 plus Then let's see here. X plus 2 divided by x plus 2 will cancel. So I'm going to be left with 2x times x plus 1 is equal to. And then x plus, I think I wrote the wrong thing. X plus 1 will cancel. And we're going to have x plus 2 times x minus 1. So now we've got a lot of multiplying that we have to do with this problem. We've got to multiply everything out, then simplify, and then solve what we can. So I'm going to bring the next step up here. So I'm going to have x minus 1 plus 2x times x and 2x plus 1 is 2x squared plus 2x is equal to. Then I need to multiply x plus 2 times x minus 1. So we're going to have to multiply x times x times negative 1, 2 times x, 2 times negative 1. We're going to get x squared minus x plus 2x minus 1. So let's simplify what we can. All right, let's see. 2x plus x plus 2x is 3x. We have 2x squared plus 3x, and then we have negative 1 over here. X squared, and then negative x plus 2x is x, and then negative 1. But I have a degree 2 polynomial, so I need this to be equal to 0 in order to solve it. So I'm going to move this x squared to the other side. I'm going to move the x to the other side, and I'm going to add the 1 to both sides. And I'm going to end up with 2x squared minus x squared is x. 1x squared, 3x minus x is 2x. Negative 1 plus 1 is 0 equals, and then all of these cancel, and I'm left with 0 on the other side. Then I can factor x squared plus 2x, and I get x times x plus 2. I set each factor equal to 0 and solve for x, and I get x equals 0, and then x equals negative 2. But I need to check, is x allowed to be negative 2, and is x allowed to be 0? Well, if you look back at the original function, what would x not be allowed to be? Well, negative 2 would make this function, this factor 0. Negative 1 would make that one 0. Negative 2 and negative 1. So x is not allowed to be negative 2 nor negative 1. But the solutions I got were negative 2 and 0. So because this solution matches this restriction, negative 2 is an extraneous solution. When I grade your work, I'm going to look for the word extraneous. So x equals negative 2 is extraneous. Therefore, our only solution is x equals 0. All right, part C. So for part C, factor what you can, multiply the whole equation by your least common denominator, simplify those fractions, all your denominators should end up canceling, and then solve your equation. Go ahead and try this problem on your own. Just see how far you can get without me. I bet you can do the whole thing. Give it a shot. So I'm going to walk you through my steps and then finish solving this problem because I feel like the explanation would just make more sense if I worked as I explained what I'm doing. So I factored x squared plus 2x minus 3 to x plus 3 times x minus 1. Then I recognized my LCD needed to include x plus 2. I multiplied the entire equation by x plus 2. I distributed the x plus 2 to both fractions, as you can see at this step. So I have x plus 2 times x minus 1 over x plus 2. X plus 2 divided by itself goes away. X plus 2 divided by itself goes away here as well. So I'm left with an equation that looks like x minus 1 is equal to x plus 3 times x minus 1. Now we need to multiply and then solve for x. So we've got x minus 1 is equal to, we're going to do a bunch of distribution, x squared minus x plus 3x minus 3. So x minus 1 is equal to x squared plus 2x minus 3. I have a degree 2 function here, so I want it to be equal to 0. So I'm going to subtract the x and add the 1 to both sides. I'm going to get 0 equals x squared plus x minus 2. We're going to factor this. Let's see, x times x is x squared, 2 times 1 is 2. If I have positive 2 and negative 1, I'll get a positive 1x in the middle. So then I'm going to get x plus 2 equals 0, x minus 1 equals 0, x is negative 2, and x is 1. So let's look back at what our restrictions would be, though, before we decide what our final answer is. So for my restrictions, I have x plus 2 and x plus 2 in both denominators. So x is not allowed to be negative 2. Thus, x equals negative 2 is extraneous. And our only solution is x equals 1. All right, I believe that's the end of our notes. So I need you now to do your extra practice and submit it, then hit the ask for help button and I'll jump in your breakout room and go over it with you. Have a good day. See you back in class.